Hello, my name is David Case. I am the CTO and Chief Architect of FYX Gaming. I've been a blockchain developer for about 3.5 years. I spent 1.5 years working in the Ethereum world, and then I've been a bit of a zealot in the Bitcoin space, especially Bitcoin SV, for the last 2+ years. FYX Gaming, we are the developers of CryptoFights and the platform on which it's built. We started development on CryptoFights in January of 2018. It was initially developed on Ethereum, and then soon after the Bitcoin SV BCH fork, we switched over to building on Bitcoin. So CryptoFights is a turn-based PvP fighting game based loosely on a Dungeons and Dragons dice-based role-playing game fighting system, battle system. In CryptoFights, players will fight against each other for cash prizes, cash in this case being Bitcoin SV, as well as build up their fighters and receive weapons and armor and other items which are all tokens on the Bitcoin blockchain, which can be bought and sold and traded and given away, and they are your property and they exist as Bitcoin UTXOs. So anything you can do with a Bitcoin UTXO as far as moving it, you can do the same thing with your property. I'd like to start off by giving you a bit of a demo of CryptoFights, and then I'll dig into a little bit of the details of how it's implemented and what tools we offer which enabled us to build this. We start off by creating a fighter. You get to choose between 3 main races: dwarves, elves, and humans. I'm going to go for a dwarf here. And from here we've got standard ability to change what they look like, what their skin color, hairstyle, all that stuff is. I'm just going to take the defaults for now. And then you have different ability points you can associate to 3 different categories: strength, dexterity, and intelligence. Our battle system is very much based off a Dungeons and Dragons type system. I'm not going to go into the details here. You can join our beta and follow along and figure out how to do all those things. All right, I'm just going to give this guy a name of DevCon. And here we go. So I now have, I'm going to skip the tutorials. I now have a fighter whose name is DevCon. This is a token that lives in my wallet. It is my property. I can trade it. I can give it, transfer it to other people, whatever. All right, now I'm going to go into the caravan. So the caravan here is where we equip our fighters for battle. So we've got different weapons and armor. Now, because this is a brand new fighter, we give you your first practice short sword for free. If you go through the tutorials, you can actually choose between a bow or a quarterstaff as well, but since I skipped the tutorials, I just get the short sword. All right, I'm going to equip him, and I'm going to go through and play one battle just to show you how that works, and then kind of go through our level up system briefly. So I'm going to enter the dungeons here. Dungeons are, these are actually bots that you're playing. This allows you to kind of play through and level up and get some item drops and learn the game before you're fighting other players. So our first bot that we're going to match here, there he goes, frog named Boggart. And here we go. So we have equipped our fighter initially with 3 different skills that they can use. They can attack, which I will do first. You can hide, which uses kind of a magical spell to hide you from your opponent, which means they have to roll a dice to find you before they can attack you. And the last thing we've got is focus, which is boosts your ability to find them if they hide, or boost your magical abilities otherwise. So I'm going to hide here just to show what this looks like. Now the point of my talk here is not to actually talk through CryptoFights. It's just to give you a basic idea of what the game looks like, how it works. But I should play out a battle first. All right. My hide missed last turn, so I'm not going to try to do another one. I rolled attack, and I have completed enough to kill my opponent. You can see his hit points right there are at 0. So now that I've won, I have a new weapon that got dropped to me. Now these are random based on the dice rolls that happen within the battles, so there's no control over what gets dropped at what times. These can be anything from poor weapons, common weapons, uncommon weapons, or even much higher, very rare weapons as well. So because I fought my first battle and won, now I get the opportunity to level up. Leveling up allows me to choose new skills to add to my fighter, or traits, where a skill is something I can do in battle. Any of these things that are in circles are skills, so I can do something like a power attack, which does more damage if I hit him, but it makes it harder for me to hit him. Or I can do traits, which are these hexagons here. I guess they're octagons. No, what are they? Hexagons? Octagons. Doesn't matter. And a trait is something that it just affects who your fighter is. So if I pick ambidextrous and I fight with two hands at one, or with weapons in two hands at once, then I get a bonus for doing that. I can also make it so I'm unarmed, which means if I don't choose any weapons, it makes me stronger. So I'm just going to choose ambidextrous for now. Actually, let me go over here. Also, we have, let me choose my elementalist here. This would give me spells to cast. So I could cast burn or shock or chill, which would all, well, they would be different ways of attacking the opponent rather than just hitting him with my sword. So, as I'm fighting battles, I can at any point go into our Hall of Memories, which kind of shows all the battles I've fought. And these are all recorded on the blockchain. So, and they can be completely replayed, and this will be stored essentially forever. So at any point in time, we could go back and see every battle that we have ever played in our lives. You can go 20 years from now and actually check the blockchain and see the battles that you played in 2021. So some fun COVID memories. I'm going to now take you to our web portal. And this is our Data Explorer. Now I'll share with you right now that this portal is definitely still a work in progress, so it's going to get prettier. But the main functionality is here. So if I look through the games, these are other games that are happening within our beta test right now, and here's the battle that I just fought of DevCon versus Bogart. So if I go in here, so our battles, the entire battle itself, every move is recorded on blockchain, as well as every level up to the fighters, every experience points gained that they get. So we can see that here is every step that happened in our battle. Bogart won the initiative, went first. You can see here he attacked me, I attacked him. Let's see, here's where I attempted to use hide and failed. And then finally I won the battle. And you can see from this that I got a practice staff as a reward, and here's the details of what, well, just what the fight was. So if I click on my fighter, which you'll notice the images don't actually my image doesn't actually line up with what my dwarf looked like, but that's, again, this is an early stage on this page. So, but I can click through my fighter. I can see every fight that I've ever fought. I can go through. I can get a log. You can even watch a video of that fight, which I'm not going to bring us through right now. Additionally, and I didn't mention this earlier, but the items that we drop have the ability to be backed by different amounts of Bitcoin. So it's not only are they different rarities, so they have different strengths and weaknesses, they also have the ability to be backed by Bitcoin themselves. So if I click into this item within our within the My Item screen here, I can actually melt this for the Bitcoin which is stored within it. Now for I'm not going to do that here, but for a practice short sword, it literally is just the dust that's stored in it. So trying to melt it will cost you as much to melt it as you'll get out of it, so it's not really worth doing. I can transfer the item, so I can send it to someone else, or I can sell it on our marketplace. This right now is using kilosats, kilosatoshis, so 1,000 satoshis as our unit of measure. I don't know that that's going to be what we're going to end up releasing with, but it works for right now. So if I sell this for, let's say, 500 kilosatoshis, which is 500,000 satoshis, I can sell the item, or list the item, I should say. And then if I go to our marketplace, you'll see there it is listed. Now this is an atomic swap system we've got built in, and it is also it's using the RelayX decentralized order lock system. So all our marketplace sales are completely compatible with RelayX's, and as theirs is also compatible with ours. And what's also really cool about this is anyone who wants to scour the blockchain for items that are listed that match, that use this lock, can actually do it themselves and can have their own shop. So I always love the idea of, if you're playing Final Fantasy or Zelda or something, and you go into the town and there's the little shop you go to where you can get rid of your old weapons and sell it to them, and then you can buy new weapons. Well, this is a world we can have where you can come to our place and do that, but also there could be listings that are just, people are just deciding to find what's available or make their own little trading shop and set up shop. And as we get to a future where there's an actual virtual world around this, you can be the actual shopkeeper in that little town, and you can list items and buy items. And I love what the picture that can do for the future. I'm actually just going to unlist this from right now because I can't actually use it. We've built much of our platform on top of Run on Bitcoin, which can be found at run.network. This is a great development platform, which if there's developers out there who are interested in checking it out, I highly suggest it. It's being used by RelayX, it's being used by us, it's being used by Duck Creations and a number of other projects out there. Probably one of the more heavily used development environments and more easily accessible development environments for Bitcoin developers. We've been working with Run for about 2 years, and I've been very close relationship with Brenton, the lead developer there, or the founder, I guess I should say. And I probably know more about it than anyone except for him at this point, because we've been with it since the very beginning. Anyways, Run, what it allows you to do is to create what they call jigs, which are, I mean, for all intents and purposes, you can call them tokens, but in reality, they're so much more than that. They are interactive, ownable objects. And the interactivity is all defined within JavaScript that's stored on chain. And the ownable part, any state changes that you do on an object are all defined within Bitcoin script, first layer Bitcoin script. So there is state change logic that exists above Bitcoin script, but at the core layer, ownership and being able to do an update on an item, or in order to being able to call a state change function, in order to do those things, you have to be able to spend your Bitcoin at UTXO that represents the item. And so that gives a ton of flexibility to combine both layer 1 Bitcoin enforced by miners script, as well as much more higher level, easy to interact with JavaScript code to build out your interactions. So I'm going to actually go to the Run Explorer to show you some code examples. Now this is our actual running in beta CryptoFights code. I'm showing it through the Run Explorer, and although you might think I'm giving you a behind the scenes look, this is actually on the blockchain. So I couldn't hide this from you. So this is all available. Everything that gets deployed through Run is unobfuscated. And if it runs standard JavaScript, for the most part, you can make it run in Run. Now, it doesn't work that great with external libraries unless they themselves are also runnable in Run. So you can't really necessarily use NPM packages with this, but as more and more libraries start building out, you can actually point to existing Run libraries. So as an example of that, I mentioned on our marketplace that we are compatible with RelayX. Now, it's actually further than that. We're not just compatible with RelayX, we're not using their API, it's not like we're cloning their GitHub repo and using that code. We're literally running the exact same code on chain, the exact same location. So when we list an item on our marketplace, it is using Relay's code. That is what is defining how those marketplace interactions work. And that is what makes it so there's complete interoperability between their marketplace and our marketplace. So I'm going to now talk through what a jig is a little bit and how it works. So a jig, as I mentioned, is kind of this ownable object. And as an example here, I'm going to talk through our fighter. So fighter that is our fighter. When we created the DevCon fighter a few minutes ago, this is what we created. And we've got our init method, which within a jig is essentially the constructor. I believe there was some issues with the sandboxing and how you could actually get to the constructor, so it's renamed to init, but this is our constructor. So when we create a fighter, we pass in who's going to own it, the race, the initial ability scores, what their appearance is, and their metadata. Those all get set as local variables. We set some initial variables that the player, the fighter, I should say, has 0 experience points, no bonuses, they're level 1, they get some basic skills. These are our attack, focus, and hide, and also an initial skill based on what race they are. So there's a dwarves or an elves or humans, we'd get different initial skills based on that. So that's our constructor, and we have a fighter as it is. Now as soon as we enter the battle, a new jig gets created. And so how our process works is when a player enters queue, they go into a queue on our server, and our server finds 2 players that are compatible with each other, or if they're in the dungeons, it finds a bot that can play against the player, and it matches them together, and it creates this battle jig. And the battle jig, in its constructor, will do various validations that the players are configured properly to fight with each other, and that the owner of that jig is actually owns the fighter and the items and everything that they're entering battle with. So when we create initial battle, we actually do this through a payment channel. So we create a Bitcoin transaction that encompasses, here are the players, here are who they're fighting, and this makes one big Bitcoin transaction. And like I said, because the ownership of everything is actually tied to Bitcoin UTXOs, this transaction template essentially gets sent around to both players to have them sign to say, yeah, they are signing on that this is a battle they're going to join, and they're doing that by simply signing the Bitcoin transaction and submitting it to our server, who then in turn broadcasts it. So that starts off our battle. So once the battle is begun, the players essentially take turns with our validator to play through until the battle is done. Our validator takes signed messages from each player and then reveals some random number and keeps track of time stamping for timing out if a player takes a minute, or more than a minute, I should say, to take their turn. Well, that's beyond how much time they're allowed to do. So we do use our validator to handle things like random numbers and timeouts. Now the random numbers themselves, I won't get into too much detail, but that is a hash chain which ensures that we are not cheating and it's provably fair. Where the timestamp aspect of this is more of an oracle approach, that you are trusting our servers, that when we say what time it is, that is what time it is. And if it took longer than a minute for a player to take a turn, that just is, there isn't really a way to handle that in a untrusted manner right now. So that is being handled as an oracle. Anyways, so as the fight goes on, we end up looking up what skill. So one of the things when a player takes a turn, what they're doing is they're saying, this is the action that I want to take. Well, we've got in here in this battle state, we'll see this battle players. We find out whose turn it is, or player to act tracks whose turn it is. We find out what skill they said they wanted to use. So we look up their skills and we find an instance of their skills. Now I wanted to show through those. So skills can be anything as simple as, here's our hide skill. It's very, very easy. It basically, what do we got here? We do This is a very long line of code, but essentially we do something that checks out if it rolls the dice and figures out if they got it or not. It puts it in the logs and it ends their turn. This is something that could be done on pretty much any chain out there. It's very simple. You could do this in Ethereum virtual machine. This is our attack code. This is not doable in any other blockchain that I'm aware of. EVM, you try building code that's, well, just simply the size alone would make this so this would eat up the entire gas of a contract. Not to mention the fact that this is just unadulterated JavaScript that we can do whatever we want with. So I'm not going to go through the details of this at all. I just wanted to show through that the different actions can be super simple or they can be really complex. And as long as you can get this deployed on chain, which means as long as a miner will take a block that's big enough to hold this much data, which that's no problem on BSV, you can make this code as complex as you want. Now, obviously, there are performance implications to making things too big, but we're nowhere near that at this point in time. So if I go back to my battle, it's going to go out, it's going to run. Oh, the other thing I wanted to point out with this code here is this is just a JavaScript class. So it extends a base class we've got that just kind of handles some things for serialization. But at the same time, this is not a jig. This is not an ownable property. This is just code that's deployed out there. So you can run this on-chain or from on-chain or from off-chain. It doesn't matter because all you're really doing is essentially requiring the data from on-chain. Requiring the code, I should say, from on-chain. So this is not a jig. This is just code. And with that, I can do pretty much anything. So in here, I actually call the run method on that. I pass in the current reference to the battle. I pass in the current state of the battle. I pass in a current dice, which are based on the random number that got passed in. I pass in the current timestamp. And what comes out is a new state. And so in that way, we basically can create actions which will modify our game state in any way that we want. And you'll notice if the timestamp is greater than the timeout from the previous turn that we set, then what we do is we actually skip their turn instead of playing out what that did. And skip turn has its own thing, which sets whose turn it is to the other player. And yeah, it's another simple transition. And then finally, after we've calculated the player's turn, we then call this end turn function, which basically just determines if there's a victor or not. If there's not, we increment the user or the player to act, set the data to tell the user whose turn it is, and if there was a victor, we set victor. Also then, at end turn, when we call this begin method, so when we first created this battle, that was one Bitcoin transaction. Then when we call this begin, that started a payment channel, and the entire battle played out through that payment channel until this end turn function is called, at which point the validator will close out that payment channel. We were actually doing those without the payment channels, where every turn was a transaction. But the payment channel approach was an attempt to kind of mitigate some of the issues that we're still having with the ancestor limits, which hopefully will be fixed very soon, and we can go back to the actually every transaction if we desire to do so. So that was the second transaction of the battle. Then finally, the validator will call the finalize method, which will then go through and actually pay out the rewards. So it does that both with the monetary rewards of Bitcoin, if there is any, as well as calling issue rewards, which is another, this is actually not a class or a jig, but this is just a regular old JavaScript function that's deployed out there. So this code goes through and analyzes based on the dice at the end of the battle, at the end of the battle, analyzes, rolls the dice a number of times to figure out how many rewards you're going to get, what quality they are, and actually ultimately what those items are. And then when that pays out, the last step here is that this battle jig itself is actually transferred to the owner. and the experience points on the jig the XP property on the jig are set. So what this means now is at the end of a battle, a player has their fighter and they have their items, but they also have the battle jig. In addition, both players are given a battle, oops, that is not it either. Oh, did I lose it? There it is. A battle token jig, which battle token is really just a way to say, hey, you were in this battle. And that helps a lot when it goes to indexing and when we look up to see, okay, what battles was a player in? Well, the fact that they owned this battle token tells us that they were in this battle. So we're using jigs here just almost as a way of just keeping track of a history of what's there. This jig is not transferable. It doesn't really have any properties at all except for just pointing to the fact that it was created from a specific battle. So by looking at that jig, I can actually get back to the battle itself, even if I was the loser and I never owned that jig. So if I go back to our fighter now, we have this record victory method. So the user's wallet, or actually the game client in this case, will at the end of that battle when they won, it will load up that fighter and it will call this record victory method, passing in the battle. And all we do here is just some simple validation that says, okay, do we trust that this battle is something that actually came from us in this case? And if we do, give the fighter the amount of XP and then destroy the battle jig. Now I want to show one other thing on the battle jig here, which is when we created it right now, we put at least 546 Satoshis in that battle. The current dust limits are about 273 Satoshis, or even lower if you're paying a lower fee than half a Satoshi per byte. By putting 546 Satoshis in this jig and having it destroyed within this function, what we're actually doing there is allowing those 546 Satoshis to become the transaction fee for this transaction. So it doesn't actually cost the player anything to spend this jig. It just costs them the destruction of the battle, which is how they gain the XP from that battle in the first place. So there's also logic here for leveling up and how additional skills get added, but the point here is this is an object, and this object grows and changes through the course of how you play it out. In order to build out CryptoFights, we've had to build out significant infrastructure in order to support what we're doing. And much of that we're going to be opening up to other developers in the coming months. We start with our portal, which I touched on very briefly earlier, but our portal includes a jig wallet, the ability to mint and melt NFTs, as well as our marketplace. We've got a crypto to BSV on-ramp with fiat coming soon. We've got the ability for games to create leaderboards as well as custom data explorers for different games. In addition, there's a number of API-based services. We handle all wallet UTXO management to handle both jigs and the Satoshis in your purse, which go to pay for different transactions. We have a run state cache, which is kind of a requirement if you're going to have any sort of performant use of run, just simply based on how their transactions build up over time. If you're going to load directly from the blockchain, it's going to take a while to rebuild the state, where if we've got an intermediate state cache, that greatly increases performance. We have a jig indexing service, which allows you to query all the jigs in your system based on who owns them, or what all the states of an instance, or all the different, you can query them by kind, you can query them by what is the current state. There's lots of different querying available through that. We have a signed message delivery service that will allow users and services to send messages amongst each other. Those are all signed with a player's Bitcoin keys. We've got a WebSocket implementation that allows push notifications of jig updates or messages directly to clients. So So this allows for real-time updates. And then we've got a jig deployment process, which allows you to deploy complex dependency trees. And it uses actually an integration with Git to determine where there has been changes and what are the implications of those changes to the dependency trees. So that is what I've got to show you. So I'd love to open it up for any questions, and would love for any of you who are interested to go check out our beta at cryptofights.io. Thank you very much.